You are welcome to Windbrain Tutor. My name is Mr. Oniko Itaiwo Emmanuel. We are going to look at introductory biology. We are going to start with science. This is our learning objective. At the end of this lesson, you should be able to define the term science, state 3 branches of science, mention 5 usefulness of science, and explain the term process of science. Now let's start. What is science? Now, science can be defined as a systematic process of making inquiry about living things and non-living things in our environment. The person that studies science is called a scientist. Now, science is systematic process, means that it does not take, we don't know when we are doing science, we don't start from the complex one. We start from the simplest one to the complex one. That it is step by step. That's what we make like systematic. We make inquiry. Inquiry simply means we ask questions. About what are we asking questions about? We are asking questions about living things and non-living things in our environment. Now let's talk about branches of science. Now there are different branches of science. We have agricultural science, geographical science, integrated science, chemistry, physics, and biology that we're about to look at. These are the different branches of science that we have. Now before we go, we have achieved our learning objective now, which is the definition of science and the branches of science. We're now going to the usefulness of science. Now, science has been proved to have its usefulness in various areas, because in the olden days, our fathers did not have knowledge of science, and so many things have affected them. These things has affected them a lot. Because of this, now come the knowledge of science. It now improve our ways of life. Now, science has been proved to have its usefulness in these following areas: agriculture, medicine, construction, technology, communication, engineering, transportation, manufacturing industry. Like in agriculture, for example, science has been proved because in the olden days, our forefathers will farm and they will be yielding their crops in low quantities. Pests and disease will be affecting their crops and livestock. But because of the knowledge of science, they have been able to develop new varieties of crops and animals, and disease-resistant crops and animals that they can be able to use, so that they can be able to increase their production and then make life standard of living to be improved. In medicine, they have developed vaccines and drugs that can cure disease of men. Because in the olden days, in the time of Plato and Aristotle, fatal diseases of always affect the people. They don't know the causes of it. But because of the knowledge of science, they are able to detect those causes of the diseases, and they are able to develop vaccines and drugs that are able to cure those diseases. In the area of constructions, they are able to build bridges, roads, airplanes, and everything, so that they are able to, because knowledge of science is one that gives them the understanding to build it. If you think about the word cement, science are able to develop what we call cement. This cement, they can use it to mold blocks, and then they can arrange blocks to build our houses, our church, our schools. Now, in the area of technology, they have developed airplanes, railway stations. Because of technology, knowledge of science and the is the one that gives them the knowledge to be able to do this. In the area of communication, like television, teles, radios, and phone, they have developed these things so that people can communicate. In the olden days, people cannot reach themselves as far as London. In the other country, they cannot cross the Atlantic Ocean to reach themselves. But in the new era now, because of knowledge of science, they have developed telephone, telex, radio, and phone, so that they can be able to communicate. Engineering, they can develop building, they can do survey, they can do and structure patterns of houses they can build. In the area of transportation, they have developed roads, so that people can move quickly from one place to another. Manufacturing industry. In the olden days, our farmers don't have knowledge how they can use their agricultural products to do. They are restricted to only one planet, but in the knowledge of science now, their cocoa can be furnished to a new product or furnished product, which is our beverage. We now get Bonvita. Now, that we're not going to the last learning objective, which is to explain the process of science. Now, what is actually process of science? Process of science refers to the sequence of making inquiry about an object or things under study in science. If you are making one, science does not, I have said that science itself is a systematic process. It does not start from one place, it does not start from the complex. You ask questions, you start from the simple to the complex. Now, science as a systematic process has various steps in which it follows. This step in which it follows is what we call process of science. It is the sequence. You know what we call sequence? Sequence means something that it is a gradual step. Now, you make inquiry about an object. Now, it is also called method of science, or you can also call it scientific approach. You can also call it scientific approach. Now, this scientific investigation, which is a sequence, now follow this sequence now, or we call it procedures. It starts from the observation, now to classification, inference, measurement, identification, hypothesis. After hypothesis, we have our experiment. After experiment, we have our control or conclusion. And after our control or conclusion, we now have our theory or law. Now, what happens is that the first step of any scientific investigation is your observation. Observation involves the use of senses to observe what you have seen and then make a tentative statement on it. That's what we call observation. Like, if I want to see this green plant now, I will use my 5 senses to look at it. I say, this plant is green. I have used my senses to view it. That is observation. After observation, I will now go to classification. I will separate them into the different groups. If I see a stone, I will separate this one look like a stone. If I see a plant, I'll say, this one that is like, see if they look alike. I will put them together. So I will now make an inference. Inference means a simple statement that, okay, all these ones are living things. All these ones are not living things. I will make a simple statement. Then after that, I will do measurements. After that, I will give them identification. Then, after identification, I will now make an hypothesis. This hypothesis is a tentative answer. It is like a theory, it is like a statement that you want, it is a statement or an answer to what you want to prove about what you have observed. Now, don't forget, it is a tentative answer. We call it tentative answer about what you have observed, and you want to prove it that it is right. Now, if you want to prove it that it's right now, you will now go to now perform the next step, which is experiment. You now perform an experiment. Now, the way we always do our experiment is to perform it in the laboratory. We perform our experiment in the laboratory. Now, what happens is that we are performing our experiment to test our hypothesis. Now, if our students want to perform their experiment, there are patterns in which they must record their experimental procedures. Number 1, there are 5 steps. Number 1 is what we call the step to register their experimental procedure. Number 1 is their aim. Number 2 is to state the apparatus. Number 3 is to then talk about the method in which they want to use to do it. Then number 5 is to talk about the observation they have seen. And then number 5 is to do conclusion. Now, aim is not about a single statement about what you want to carry about. It is what we call the aim. The apparatus is what are the instruments you want to use to carry out the experiment. The method, it is which way you want to carry out this experiment. It is like, you don't let the method to be too much. The method can just be only 5 steps. It can be only just a step, 5 step. Like if you want to boil your water now, or you want to cook rice, you say, first of all, you light the stove. First, step 1. Step 2, you put water on the stove. Step 3, you wash the rice, you put it on fire. Step 4, you allow it to cook for 5 minutes. Then step 5, it has cooked. You can see that it is 5 steps. So that is what we call step results. Then the observation, at the end of the experiment, what do you see? That's what we call observation. Then what does the experiment conclude for you? What is the result of the experiment? It is what we are going to write in the conclusion. Now, after the experiment has been performed on the hypothesis, if the hypothesis is true, and so many other scientists has been performing the experiment on that tentative answer, and they found that it is repeatedly true, the hypothesis will change to theory. The hypothesis will change to theory, but if it is repeatedly tested and found that it is not true, it will be discarded. It will be discarded and say it is not a true hypothesis. Now, if the theory again is repeatedly tested again and it is found that it is true, then it will change to what is called law. It will change to what is called law, and then from law to what we call principle. So that is what we want to talk about in this first series of our learning tour, Windbrain Tutor. Please, I just like to do a recap of what we are talking about. We define science, we state the price of science, we talk about usefulness of science and the process of science. Please, you can be able, if you want to learn very well, please reverse what we have talked about and then subscribe to the video and enjoy it in your free time. Thank you very much for your time.